Hi everyone and welcome to the video on the area between two curves. This is really an application of finding the area under a curve, so please make sure that you check out those videos first and that you've completed the related exercises. What I'm going to do here is, I think a good starting point for any of these questions, if you're not provided with the graph, is to actually sketch it out first so we can see what it is that we're looking at. So find the area enclosed between y equals half x squared and y equals 2x. Well, half x squared is a parabola, it's positive, it's got a dilation factor of half, so it's going to be a little bit wider than usual. There it is. And y equals 2x is a straight line passing through the origin, so it's going to go off like that, and well, down this way here too. So that's very roughly what it is that we're looking at. We're looking for the area enclosed between the two graphs, so that is this area just in here. We don't worry about this part here because this isn't actually enclosed by the graphs. This here opens out further and this keeps opening out as well, so it's not enclosed. So we're just looking for that area right there. Now, as I said, this is an application of the area under a curve, and I'll show you why. So if I were to do the area beneath the straight line, it would be all this part here. Okay, right up to that end part. And if I were to do the area below the parabola, it would be this part. So what you can see is that I can get the area between them by doing the area under the straight line and then taking away the area underneath the curve. If I take away this section here, it's just going to leave me with that bit in the middle there. So that's exactly what I'm going to do. To set this up, I need to first know what the points of intersection are. Now, one of them is pretty obvious, that's the origin right there. The other one isn't so obvious, so I'm going to need to do a little bit of algebra to figure it out. So to find where they intersect, I'll put them equal to each other. So half x squared equals 2x. I should make a note, this is 4 points of intersection. So probably a good thing to do here would be minusing 2x on both sides. So half x squared minus 2x equals 0. I'm also going to multiply by 2 just to get rid of that half. So then I've got x squared take 4x equals 0. This is a quadratic equation, so we need to factorize to solve. So I'm going to take out the common factor of x, and that leaves x minus 4 equaling 0. And therefore, as a result of that, we've got either x equals 0, which is our solution that we already knew, or using the null factor law here, x is equal to 4. So those are the two important x values. Now, that means that I need to do the integral between those two places. So the area is equal to the integral between 0 and 4 of half x squared dx, and then I'm going to take away, whoops, I did it the wrong way around. So that's meant to be the integral between 0 and 4 of the upper curve, which the upper curve in this case is the straight line. So that is integral between 0 and 4 of 2x dx minus the integral between 0 and 4 of half x squared dx. And now it's just a matter of working this out, so that's equal to 2x squared on 2, which is just x squared between 0 and 4, minus, and that becomes half x cubed on 3, which is x cubed on 6, between 0 and 4 as well. So that's going to be, well, subbing that in, 16 take 0, and subbing the 4 in here, 4 cubed is 64 on 6 isn't going to be all that nice, it's 10 2/3.